Hello, everyone, and welcome to this first session in our 4-session series following up our release of the Deepfield Network Intelligence Report on November 17 this year. In that report, we covered the major impact and effects of the pandemic on service provider networks and the internet as a whole. And in this session today, we will be focusing on the impact of video streaming services on networks. My name is Alex Pavlovic. I'm the Director of Product Marketing in Nokia Deepfield, which covers the portfolio of network intelligence, analytics, and security applications. And today I'm joined by my colleague Jerome Meyer, located in Hong Kong. Jerome is our business development lead for Asia Pacific region, working directly with service providers in that region on Deepfield applications and installations. So before we start, it's worth just to take a look at what happened earlier this year. We know that internet has grown so big over the last decade or so, and the pandemic created such a terrific impact on the internet and on service providers' networks earlier this year, and continues to do so in the subsequent waves of this pandemic, unfortunately. So more than ever before, we understand the importance and criticality of our residential networks from which we work, entertain, communicate with others, and continue to use them as really our lifeline, literally and figuratively. We noticed that traffic has significantly grown since the beginning of the pandemic, and most of that growth has been attributed to the video services because they are the most demanding. We also live in an age where service providers are increasingly concerned about what's going on in their networks and services. And a lot of questions these days revolve around what type of applications are flowing in their networks, how do they get in there, how do they pass through all the different stages or really segments of their infrastructure, how do they affect their network and service delivery chain, but most importantly, what is their customer experience and what is the expected quality of that experience from the end user's view. So in this session today, as I mentioned, we look specifically on video services or streaming video services to be more precise. Over the last decade or so, we have really entered a big era of online streaming video services in which which are largely replacing classical or linear television as we knew it. Today, we have a situation where the major online service providers such as Netflix and Disney Plus have amassed extremely large number of subscriptions. So Netflix is now reporting more than 190 million subscriptions worldwide, while Disney Plus has amassed more than 74 million subscriptions as of October this year, really much ahead of their 5-year plan, in which they plan to have anywhere between 60 and 90 million subscriptions by 2024. So we have more choice than ever, and a lot of people are not just cutting the cords; they're also switching to multiple online video subscriptions. So it's really creating such a very important effect on networks because service providers often don't see where all of these video services are coming from, and they cannot really attribute them properly to particular online video providers. As a matter of fact, on November 11th this year at 7:30 p.m. Eastern Time, there was an interesting thing that happened. For approximately 90 minutes, YouTube videos were not available. YouTube service was working, but the videos were not playing, which caused a major shift to another video service provider, Netflix, which experienced a 20% bump in the same period over the previous night. So obviously, from a macro perspective, this is impacting our experience of video services. But Jerome, you work with the service providers. Can you tell us what did this mean for service providers, and what effect were they able to notice here?
So first, yeah, I think it's definitely it's really cool to see first those insights, but it's really useful to understand for network operations team what those real-time insights mean for the impact of the video traffic on the network, right? And although this was quickly acknowledged by YouTube and Twitter, our Deepfield customers saw it even quicker. But I think even more strikingly, what we saw so as a result of this switchover from YouTube to Netflix for about 90 minutes is that for a single one of our US customers, and that meant several hundreds of gigabit per second worth of traffic that suddenly switched over from one service to the other. And even though you could argue that video streaming is not particularly latency sensitive, as it's not real-time traffic like voice calls or online gaming or video conferencing, but the sheer volume of traffic that is simply the majority of what most service providers carry on their networks. And if we take the analogy of the internet being the highway, video streaming is kind of the equivalent of the trucks that drive on it. They're big. They may not go as fast as some cars, but if your highway cannot accommodate them fast enough, then you start getting into trouble. And I think if we bring it, full circle to the YouTube outage example, while to a subscriber it is transparent to switch from YouTube to Netflix, it's pretty easy, right? But to a service provider, there often is a big difference as the traffic flows to a different path. And that may mean that the peering with Netflix suddenly sees a 100% or 150% increase of traffic volume happening in just less than an hour. And that is huge. And I think what really makes it so interesting is to see how we can really help bridge the subscribers' expectations of the network, which has a direct business impact on our customers, and how the networks dynamically adapt with, of course, the hard work of network operations team to make that happen so that it just works.
Can you also let us know what are the options for service providers when faced with all these online video services today? So I understand on one hand, they are providing this connectivity to internet to their end customers and subscribers. But in some cases, they're even providing similar services themselves. Maybe you can just give us just a range of options what service providers have on their plate for dealing with video services today.
Yeah, definitely, Alex. I think that's questions that many of our customers and our service providers have been pondering for the past several years. It's true that it leaves this situation with streaming services and where content is coming from leaves the service providers in a bit of a predicament, which is again not new. But the content providers are capturing much of the value of so in the value chain, while they leverage much of the existing infrastructure. So some service providers will focus on providing this bit pipe connectivity, so to speak, so to providing the best possible connectivity to the end subscribers, regardless of what carrying, what kind of video services are traversing the network. While some others will want to climb up the value chain and either provide their own video distribution service like Orange in France, or even, I think to a bigger extent, AT&T in the US with their acquisition of HBO, for example. So some will make their online video distribution, so they will make some deals to be part of their service plans. And we've seen that happen again and again in different countries to integrate this video offering either from whether it is Amazon or Netflix as part of the service provider service plan. But I think what's really important is, regardless of the model that the service provider chooses, the need for visibility when it comes to streaming video still remains. It matters a lot for network planning because streaming video is the majority of the traffic. So we just checked earlier, and still today, the streaming video, for example, in one of our customers in Asia Pacific, is close to half of the total tonnage of traffic that traverses the network every day. So ultimately, it's really about enabling and really making sure that we can plan ahead for this majority of the traffic, and also to ensure that subscribers are happy with the service.
Interesting that you mentioned tonnage, because we have two parameters for quantifying the effect of this traffic on the network. One of them is measuring the peaks. So we take our perspective also on the peak viewing times, which are usually the weekends, anywhere between 7 and 11 p.m., Saturday night or Sunday night. And those peak traffic times which really go back to how we designed telephone networks a long time ago, are also now used to dimension the networks for delivering service at those peak times. If the network is able to deliver all those peaks, then we're fine. But you also mentioned tonnage, which is really the total volume of the traffic, which is another important parameter to look at when we talk about networks. So going back to the impact of the pandemic, not only our lives were changed, but also our network behavior changed quite a bit. So as we noticed the increased video traffic in some networks actually saw the increase of video traffic by 75% in a matter of a day, or the first weekend after the lockdown measures were introduced. So when we look back at the longer term perspective from, say, February, March, all the way to September, October, we were also concerned whether this increased video traffic was the result of people watching more content or more people watching content. And interestingly enough, from our North American service providers using Deepfield portfolio applications, we realized that we noticed a number of new IP addresses that have never used before, public IP addresses, specifically in the context of video streaming. So we can safely say that in North America, this result of the increased video traffic was mostly because of the increased number of endpoints watching video, set-top boxes or customer routers at their homes. And it increased by 30%, so, which is really very much in line with what we are hearing from all these online video providers in their quarterly and annual calls. As I mentioned, our online behavior also changed. So in the past, the peak viewing times were the weekends, and we kind of had a dichotomy between the major online providers, say Netflix and YouTube. People were watching YouTube probably continuously during the day, while Netflix streaming was a bit reserved for the evening hours. That all changed with the pandemic. So we saw streaming, both Netflix and YouTube, starting very early in the day and continuing, prolonging throughout the day, even not just on weekends, but also on weekdays. So on this graph here, we see that 60% of peak traffic was reached by 1 p.m. or 13 hours in North American networks during the week. So this is really quite a lot of load on the networks. So in many networks, this increased traffic, this influx of video traffic, came as a kind of a two-stage process because, and Jerome, you will explain to us this in a second, that most online video services or providers work jointly with service providers, and they place their content as close as possible to the end users in the form of cache servers. So we first saw the exhaustion of these cache servers, and then the influx of additional traffic over peering, which in some cases it's even directly attributed to the money that service provider needs to pay to their transit or providers in some cases. So all in all, normalization of this traffic appeared of the first wave of pandemic between May and June, and in some cases took a little bit longer, such as Spain later in July. Can you just give us, this is the macro really perspective, can you give us what was the most concerning thing from a service provider perspective during the same times?
Yeah, Alex, so definitely I think when we talk about the impact on video streaming on the networks, I think it's important that there are several aspects at play, right? From if we start from the subscriber perspective, so first on the access network, I think whether it is GPON or DOCSIS or DSL, I think they are asking themselves, is that providing enough capacity? And what we've seen definitely is that that's not typically been an issue for most service providers, at least not of our customers, because especially since video streaming is more on the downstream, so there is not so much contention here. Then same question for the backbone. Again, here, no particular issues. But when we really address the video streaming question, the most critical aspect, as you said, are really CDNs, so the content delivery networks, and the peering. CDNs, because it allows for a lot of the video streaming traffic to be served locally from within the service provider network. But then when specific content is not on the local CDN cache, that means that needs to be fetched from the internet, which means that needs to go to the peering on the transit edge, which has finite capacity and can be expensive, right? And what we saw happen especially early in the pandemic, so so let's say after, I think, March, April timeframe, as you said, so there was, I think, a lot of our customers were getting worried about the capacity, especially on the peering edge standpoint and on the cache standpoint. And there was a concerted effort between the content providers, at least the major ones, and to proactively reduce the quality of the video, so the bitrate of the video, to make sure that this could be clawing back some of the engineering headroom that was built into the network. Because of course, as you said also, when network engineering teams build networks, there is normally enough room for peak traffic, but also to accommodate for the growth that is coming, for the coming year. So without reduction in average bit rate for those major providers, at least the main ones, because again, Disney Plus was in the middle of their launch, so they didn't reduce it, as you can see here. But there was effectively a reduction of the total traffic per subscriber. So still there were more subscribers and there was more traffic per subscriber, but still overall that reduction by those main, so Netflix, YouTube, and Amazon Prime Video content providers alone, since they were the largest one, managed to at least give back some breathing room to the network while this was happening in the early days of the pandemic.
This is quite an interesting thing because as the European Commission was contemplating regulatory measures, these service providers took a voluntary move to reduce their speeds, not to be subject to any such regulation. So, and I think, as you mentioned before, video traffic has one particular distinction from all other types of traffic, that it's elastic. So even if the speed is reduced, this actually, translates to slightly reduced quality of experience, but not the interrupted connection. So which means that users can continue to enjoy video services. Okay, probably not at the HD or high definition level, but still they will continue to enjoy movies and TV series they like. But from a network perspective, then again, what are the major impacts from as what did service providers who use network Deepfield portfolio of applications see in these particular cases?
So in this particular case, so we saw definitely the direct impact of the bitrate reduction in terms of so we were able to measure the pre and the post reduction through one of the applications of Deepfield called Service Intelligence, where we can measure at a per stream level the average bitrate that each individual stream takes over the network, which of course is a proxy for the quality and for the definition of the video itself. That gives a measure of what is how many megabits per second each stream consumes on the network. And you can see here that we have when you look at the peak traffic, so before and after the lockdown started, and after the speed reduction. So we saw that the peak overall reduces, which is exactly what the content provider and even the European Commission considered, even though it was not directly put in effect by the regulatory body. But we saw these peaks getting reduced, and overall, so even though even despite those reduction of bitrate, still the aggregate traffic grew, but at least that provided a bit of runway especially for the network operations team to manage within this very tight period. Because again, I think we have to remember that especially this early on during the pandemic, nobody knew if the growth was going to continue, or how far it was going to go. So I think there was definitely a concerted effort that took the service providers, the content providers, and even to some extent the governments of some of the countries where our customers operate, to really reduce and mitigate as much as possible the impact on network. And this was really enabled, and they were able to really concretely measure and have data inputs as to what the reduction from the content provider, which the service provider had no real control over, but really see the direct impact it had on the network.
Great. Very interesting information. So, going back to the service delivery chain, you mentioned that video traffic can be delivered from within the service provider's network and from outside. We also see that both Netflix and YouTube are ranking different ISPs, internet service providers, by the quality of services as experienced on their network. So, obviously, delivering services, video services, is becoming a very competitive game for service providers. That's how certain customers make their decisions to choose one or another. Can you just throw a little bit more light on that service delivery chain and what were the changes that we saw during the pandemic?
Right, absolutely. So I think so when we look at what was happening, for example, in one of our customers in Europe, so what was happening before the lockdowns took effect, roughly 2/3 of the traffic were coming from the local on-net caches. So meaning that the remaining third of the total Netflix traffic was coming from the internet, so through the peering routers or from transit links, so external to the network. What happened after this, after the first week of the lockdown, is that since there was more demand for video, meaning that the overall traffic for streaming video grew, some of that growth could be accommodated by the local caches, but it was not enough. So the local caches have a finite capacity, and that meant that there was a lot more growth on the peering edge. And when you talk about peering edge growth, I'm sure that this is something, and this is a topic that that the network operations team in particular, can get nightmares over because it's you have to plan this ahead, and often it can take time, especially during a period of lockdown when you may not be able to go to the site to add capacity on the routers or to arrange with the peering partners to accommodate all that. So it is not straightforward, and this is so. Of course, there was a lot of work that was done to increase the capacity on the peering, and also in parallel to try to increase the cache capacity, because of course, augmenting the peering and transit capacity has a financial impact. So of course, that means you have a lot more traffic that comes through the network. It means that you have to pay to transit partners, for example, when you have some transit traffic. So this is something you need to accommodate fast. And here we can directly see the impact, again, through the analytics and the insights that Deepfield can provide. How much of the traffic for video is coming from within the network, and how much is coming from outside the network. And this is really a key metric that a lot of our customers are paying a lot of attention to.
Let's dig deeper a little bit into this topic. I think this is a very interesting topic because it's not a trivial thing to figure out which traffic, which IP flows are video flows to start with, and also attribute all of them to the same online video provider. Because while Netflix or Facebook Video or other online video providers have extensive analytics on their side, all of these analytics are either not important or invisible to the service providers. So from a service provider perspective, what are the most important aspects of video, and how do we provide that visibility when it's all about IP flows, right?
Yeah, no, I think definitely it's. I mean, there are a couple of things that are really important when considering, how the streaming video traffic is going to be traversing the network and what impact is going to have on the network. I think the first one is really about how does the video enter the service provider network, so this peering and transit view that we just talked about. And second, how is that flowing through the network, and how do we characterize it? So the view across the entire network. What is the average bitrate to understand what is the quality? Are there some anomalies on certain parts of the network? How many streams are there for a particular service? And third, how are the video services consumed on the network? And then here we can slice the consumption by different slices of insights, whether it is per subscriber or different dimensions that we can really report on to really understand what's happening from within the different parts of the network. And as you said, I think it's not easy, right, to categorize the video traffic and to understand what it really is, because of the way the video service delivery evolved over the past decades. Because as you said, it's a lot of the content providers today are using a multi-CDN delivery. So that means we really need to understand and to be able to do this pretty accurately and to understand what this means for the different providers. And taking the example again of Disney Plus for their launch, for the launch that they did in Europe, at least in some countries in Europe this year, they used 6 different CDN providers, including, for example, Edgecast and Akamai, which are some shared CDNs. And that means that some CDNs can deliver content from multiple providers. For example, again, taking the example of Edgecast, they can deliver content from Disney Plus, but also from Rakuten TV for those in Japan and a bit elsewhere, and many others. So it's not enough to just map IP address blocks like people used to do before to a service. So it really matters to have this visibility, and this is really what some of the functionality that Deepfield can provide to make sure that the content that is flowing onto the network, for which we need to provide context, and this is really why the context and the visibility that Deepfield provides really matter.
You also mentioned parameterization of the service itself in terms of number of streams, concurrent streams, and ABRs, or average bit rate. So that's how we quantify the end user experience, and that's how we track and benchmark one video service or compare one to another. Also look at the impact of delivery from off-net, on-net perspective. Can you also give us, from your experience, some examples? What other types of insights are service providers looking into or for when using Deepfield applications? What are other use cases that they are exploring as they look at video streaming in particular?
So some of what we can do, for example, is to help our customers understand what is the delivery supply chain, as you said, and the consumption chain, also to some extent, of the video services, and to help them make the right network investment decisions. And this is, I think, really where having these insights really matter, right? Because once you have the data, once you have the right insights to understand where the content is flowing, how it is flowing, which parts of the networks are more affected, then you can really add capacity where it is needed the most. And you know where to add a cache, where it will provide the biggest relief for the peering edge, and much more. So to me, it's really about making sure that the investment goes into the right places, so maximizing the return on investment for the team who has the budget, basically, for the network. And we've seen also some other use cases where, for example, let's say the high tonnage of the video traffic drives the importance of optimized traffic routing. So here in Asia Pacific, we had a customer who wanted to make sure that the traffic entered the right ingress point into the network, and the reason was simply that they have it's a country with multiple islands, and so the connectivity between the islands is with subsea cable, and again, the subsea cable capacity is finite, so you need to make sure that the routing is optimized so that you don't waste capacity on that cable. Another one that we saw is that you can proactively monitor the quality of experience from your subscriber standpoint to make sure that you quickly react and correct issues that may affect them before they call your call center. Because, of course, when there is an issue on Netflix, for example, in a region, your customers will not call Netflix, they will call you. And this is what really where we see. So proactive monitoring makes a lot of sense. Whether that is to, for example, quickly diagnose that there is a peering link that is becoming a bottleneck, or there is a new cache that can provide better performance, for example, if it is put at the right location, for example.
Can we go back to, I guess, some of the advantages of Deepfield approach over the legacy approaches that we have seen in this area, although I think we're taking quite a novel approach with big data analytics here. So apart from the things that you are able to see on the screen on your user interface or pass to other systems via API, my question to you is, how quickly can Deepfield provide me as a service provider with all those details about a particular video online service, and how it's attributed, or how it's delivered over different CDNs? So say if there is a new service that is being launched, how quickly can I, as a Deepfield user or customer, can get that information, and how do you know that? How do you get that information yourself?
So I think that's really the beauty of Deepfield, right? It's that it is a software-based solution based on a big data engine that can really scale to the entirety of the network. And compared to what was, let's say, the previous approach, which was more based on hardware that you needed to move around, whenever, if you could afford to spend it in some parts of the network. With Deepfield, you get full visibility across the network, which means you can also put in place this automation that will really look at what's happening in real time on the network, and then derive some automation depending on some criteria that you set. And so that can provide some very interesting features, like, for example, you can take a look at what services are growing the fastest, even if it is, for example, a new small up and coming service that is not very well known. But at least if you get for example, if you set an alert saying that, so you have this much growth, week over week or month over month for this, for any service that is related to video and that has a significant impact on the network, then that gives you a lot more, that gives you a head start on the network planning and making sure that you can start to put in place those peering links, or you can put in place those caches on the network, so that you provide the best quality of experience to your subscribers. And excuse me, that in turn helps you reduce your churn rates and helps your bottom line, right? So it's really, really a way to leverage the data from your network and making sure that you can translate that into insights that will have a direct business impact.
Hey, Jerome, there is our secret sauce called Deepfield Genome, which really consists of Deepfield Cloud Genome and Deepfield Secure Genome. Can you throw a little bit of light? What is Deepfield Cloud Genome, and how does it help in better understanding video traffic in this context?
Yeah, so like we discussed a bit earlier, so matching the data flows to services is more complex than ever before, since the delivery chain really often involves shared CDN infrastructure to deliver the content at the lowest cost, and especially so for video traffic, right? So as you said, Cloud Genome is our secret sauce as Deepfield. And with Genome, we really monitor and categorize billions of IP endpoints. So our customers are really able to understand the context of the data that flows onto their network. And much of this genome, let's say, data gathering is automated, and we categorize it through heuristics and machine learning rules to really do this at scale, because of course it's scale is really the name of the game here. And for example, we can tag certain IP addresses against specific CDNs and some specific video content providers. So if I take back the example of before, we can take the Disney Plus service and map it against the different CDNs to understand, which is corresponding to what. And when our customers combine the data from their network and the Cloud Genome data feed we provide to them on an hourly basis, it is then that the magic happens, right? They get access to the real-time insights, as well as the historical reports that makes them that help them to make really better business decisions. And really, the beauty of this is that this happens completely through software, and this is really what makes Deepfield and Genome so interesting and compelling, is that you don't need to have expensive, dedicated hardware probes that some of our customers used to move around the network because they were too expensive to cover the entire network. So with Deepfield, you can really cover the entirety of the network without having to move those hardware equipment around. And not only does that enable to really know what's happening on the network in real time, which can be really a game changer for different teams in our customers, but really made all the difference when looking back at the beginning of the pandemic. One of our customers in Europe told us having Deepfield and having this visibility was the difference between guessing more or less what was happening in the network and being able to sleep at night because they knew exactly what amount of traffic, what was the growth, where the growth was happening, what was they had some idea about the forecast. So it's really a huge deal in terms of the visibility it can give to different teams in the service provider networks. And it makes the planning for the network expansion and the modification of the network architecture a lot more grounded in data. And especially as we talk about video streaming service, again, this is the majority of the traffic in terms of total volume, so huge impact. And with that, it makes the entire difference between, in terms of the return on investment you get from your network. Because again, instead of guessing where the capacity is going to be needed, whether it is on the backbone, on the access, on the peering, you exactly know what is needed and where. So it's really a huge step towards also making sure that you can maximize your return on investment for all the capex that you spend on the network. And I think finally, and just as importantly, with Genome and the rest of Deepfield, it's really a big step towards network automation. So it's really with Deepfield that we can provide those network insights that are required for the automation piece of the network to make the right decisions with all the necessary context that we can then provide at scale.
Thanks so much, Jerome. And I would also like to thank the audience for spending 30 minutes with us today. I hope they will join us in subsequent sessions on gaming, VPN and video conferencing, and DDoS security in particular, which we will be delivering in the next year, 2021. Please join us again. Please download the report following the links that will be available with the announcement of you can see in the screen right next or in the chat window. And hope to see you again. Thanks so much.